All right. So for this first question, we're talking about how the Kool-Aid tastes and which one you're most familiar with. That is a total opinion question. You could have written any of them. As long as you put why, that's what you needed to have. For number two, it's asking you, well, what is the actual concentration of Kool-Aid? All right. So they give you 1.5 tablespoons of powder and 1 cup of drink. So the powder right here is what we call your solute. That's the thing I'm dissolving. And the 1 cup of solution is over here. Solute needs to be in moles when we're doing molarity. And the solution, that needs to be in liters. So I'm going to whip out some dimensional analysis. 1.5 tablespoons. There are 1 tablespoon for every 11.4 grams. I can go from grams to moles using the periodic table, 180. We calculated that earlier. And that gives me 0.095 moles. And then a cup, well, I see here that a cup is 237 milliliters. So I'm going to divide that by 1,000 to get liters. And I get 0.237 liters. And then molarity is just to take your moles divided by your liters, and you get 0.4 molarity. I'm going to write it over here because I'm out of room. And there you have it. So for molarity, you just need to find your moles, you need to find your liters of solution, and divide the two. No matter what they give you, you can always find that. And I'm going to erase this because we're going to write down here. Okay, so that's how you find molarity, and so therefore the middle one was correct. The one that we put 7.2 grams in 100 milliliters, that was the one that Kool-Aid recommends. All right, next one. How could you express everything using molality? For this one, molality is moles of solute, my NaCl, over kilograms of solvent, that's my water. So in this one, I needed to go from 3.6 grams of salt using the molar mass. I go to moles and I get 0.0616 moles. And then I need to get 100 grams into kilograms, so I divide by 1,000 and I get 0.1 kilograms. So therefore, when you take your moles divided by kilograms, you get 0.62 molal. Okay? All right. How would you express it in parts per million? Well, parts per million is milligrams over kilograms. So I would take my sodium chloride and turn that into milligrams. And for every 1 gram, there's 1,000 milligrams. So that gives me 3,600 milligrams of Kool-Aid. And I already calculated my kilograms, so I'm just going to take that down. Take my milligrams, divide by my kilograms, and I get 36,000 parts per million. So hopefully you picked up in the video, parts per million is used for very small amounts, okay? That's because you get these really big numbers if you try to do anything like soda or any concentration we would do in the lab. Parts per million is mainly for the environment. All right, draw this solution on the molecular level. Now what I saw was a lot of people just drew something like this, where they had dots, you know, and then they had maybe some different colored dots in there in order to show that it had mixed together. But remember, whenever we draw anything on the molecular level, we want to show what the actual molecules look like. So I want to see water. Okay, and we all know that water hydrogen bonds. So I'm going to have an H and an O, and they form a hydrogen bond. The H's are going to like my chlorine ions because sodium and chlorine break apart. Hydrogens are partially charged positive and chlorines are negative. So the chlorines are going to like the hydrogens, and the oxygen is going to like the sodiums. So that's what I was looking for on a molecular level. Okay. All right. Intravenous solution. So we want to find molarity. So again, I would need my moles of solute and I need liters of solution. So I'm going to take 5.10 grams. Again, I use the periodic table, the molar mass, to get the number of moles, which is 0.283 moles. And then for this guy, I get 0.01, excuse me. It's not a zero. There we go. All right. 0.1005 liters of my solution, because molarity is moles per liters of solution. And when I divide those two, I get 2.82 molarity. Okay, winding down. So I guess the best thing for me to review with you is there are many different ways to get concentration. You can use molarity, molality, or parts per million. We rarely use parts per million unless you're in an environmental science, okay? We don't use molality except for colligative properties, which you'll learn about later. Molarity is the one that we really like, moles per liters, and it's the one that's more common over when you go into a lab or anything like that, okay? All right, but many different ways. All you have to do is identify your solute, identify your solvent, put them in the right unit, and then divide. So with number 5, it said describe the similarities. And for these, I saw some things like they both do concentration. They both tell you concentration. They both deal with moles of solute, okay? And those are all true. But a big one that I would like you guys to know is molarity is solute, moles of solute over solution. And molality is moles of solute over solvent. Oops, I didn't write the right thing. There we go. All right. So in this one, this is a part out of the whole. So molarity is a percentage. It's part out of the whole. This one, molality, is solutes over solvent. This one is a ratio. You're comparing how much solute you have to solvent. So the biggest difference between these guys is that, yes, one of them is the solvent and one of them is the solution, but because of that difference, you're actually calculating a percentage versus a ratio. All right, final one. And I'm not sure, my screen won't slide. Oh, no. So what I'm gonna do is, please join me. We're gonna do number 6 up here because I can't make my screen work. All right, last one. How much ammonium chloride in grams? So that's the thing that I'm looking for, is ammonium chloride. Is needed to produce 2.5 liters of a 0.5 molar solution. So in this case, instead of asking me to solve for molarity or molality, it's more like our pre-lab questions. I'm asked to solve for the grams, okay? Molarity can also be written as moles per liter. I recognize that moles can be converted into grams if I use my conversion. So what I'm going to do first is I'm going to solve for moles. And in order to do that, I need to multiply my molarity times my liters, 2.5 liters. And my liters cancel out, leaving me with moles. So when I do that, I get 1.25 moles of solute, my sodium chloride. And then I know that if I go from moles, oh, I ran out of room, sorry guys, moles to grams using the periodic table, I can find the grams. So I calculated the grams for ammonium chloride to be 53.49 grams. And when I multiply those sides together, I get 66.86 grams, but with sig figs, it is 67 grams. So in other words, number 6 is asking you, if I want a 2.5 liter solution, and I want it to be 0.5 molarity, how much solute will I need? I will need 67 grams. I take 67 grams, I mix it in with 2.5 liters, and I get 0.5 molar. All right, so that is the Kool-Aid lab. Hopefully that helps you and clears anything up for you. Please let me know if you are still struggling with these concepts, because we will be using these conversions and these equations in our next portion, so it's important we understand this. All right, you'll need them for rates, you'll need them for colligative properties, and you'll need them for equilibrium. So let me know. I can make you a video, or we can chat, or whatever you need to have happen. All right, good luck with today's work.